Alright, our next thing is a much needed project that I've been hoping to do here for a while. I just got these in the mail from eBay, and as you can see, they are 300 watt 8 ohm power resistors. And what I'm going to do is I'm going to build a new dummy load for testing amplifiers that's a little more convenient than the setup I have now. Now, if you want to look at what I have at the moment, this is it. This is my current dummy load, and it's basically just two 8 ohm 100 watt resistors. They're much smaller if you compare them in size. A little bit different. And what I've done is I just have a CPU heatsink, an old aluminum one, with the fan on it still. And I mounted these on, drilled and tapped it out, mounted these on there, put a couple of leads here that took, I soldered some wires that goes into the amplifier. And then this is where we connect our meter or our scope or whatever. And it's worked pretty good up until this point. But I would like to get something that can handle a little more load, and it's a little more professional, that I can just plug some BNCs directly into my scope or whatever. Have a couple banana plugs that I can connect a meter, meter probes, and a couple other features. So this is what we've started out with, and I've come up with a little bit of a mounting system for it. And so let me get that up on a bench and I'll show you here. Alright, so I went to my local supply shop. There's a kind of a surplus store that sells like surplus windows and sheet metal and stock, aluminum stock, metal stock, plastic, all kind of cool things. It's called Star Supply. It's just a local business, been around for a long time. And I picked up a piece of this extruded aluminum square tubing, or rectangular tubing I should say. And what I did was I took my, just took an orbital sander with like really fine sandpaper, and I went over it and kind of polished it a little bit. And then I went, and luckily these just fit perfectly on either side. So what I did was I marked and drilled and tapped 8 holes, as you can see, on each side. And what I intend to do is I'm going to put some heatsink compound on here and mount one on each side and kind of make what we call a cooling chimney. Now in the X-ray business, this is where I got this idea from. We use this same material, or the manufacturers did. We had some great big transistors, power transistors, for a power supply, and they would mount them to this, and then they would set this upright like this, and they had a fan underneath that would blow upwards, and it did a fantastic job of carrying away the heat very quickly and actually being able to handle more energy than the transistor was really rated at. So it did a very good job. So my intent is to do the same thing. Mount these up here, kind of like that. And then I drilled a couple of holes in the back. Let's see, get that in there so you can see it, for mounting. And then kind of did a sloppy job on this, but it's something's going to sit under my bench as a piece of test equipment. It's it's not the most professional, but I made a little wooden box, and all I did was I just took some plywood for the back, and you can see where I drilled out for that aluminum. You notice this is further down on this side than it is on this side. Down here is where the fan's going to go. And on the top, let's see if we can look inside, you can see how I cut this out inside. That's going to be my my actual control panel, where all the jacks and connectors are going to be. and I just used the some of that 3M spray adhesive and sprayed it on there, and then I just kind of fused this piece of aluminum to the front. So it just kind of made up. And really, if I really wanted to go crazy and make it look professional, I mean, I could paint the wood and do all that. I might do that. I'm not sure yet. This is kind of a work in progress. I had this fan. I don't even remember what I pulled it out of, but it already has a power cord with one of these little switches and a little strain relief that we can mount. And I cut this box so the fan perfectly fits in this width right here. So it should be pretty easy to mount down there in the bottom. What I'm not sure is if I'm going to put some feet on the bottom, you know, to allow airflow and set it up this way, or if I'm just going to like mount it to the wall or something. I would love to wall mount it, but I've pretty much, to make a confession, I've run out of wall. There's you collect as much junk over the years as I do, and you start to wonder whether now you're an electronics hobbyist or a hoarder, and I'm starting to question myself on that, but that's another conversation. Anyhow, when I find some room for that, I'll mount it up. On the front, I have collected up these things. And I'm basically going to take, I have these, and basically one set of these will go to the amplifier and connect to the terminals on the resistor. And then the other set will be a gazouta that we can go to an external set of speakers or to a meter, put meter probes on there like an output, and they'll just be in parallel, you know, kind of like that. And then I put a set of switches here, which I will be able to turn, you know, kind of to turn on and off the outputs. So if I wanted to connect speakers to here and switch this over to speakers or switch it over to the dummy load, I'll be able to use that switch to toggle back and forth between speaker and dummy load. So this can serve as an output, or it can also, you know, from the resistors, or it can serve as an output to speakers where it'll just loop it from here into here and bypass that. So that's kind of what I'm thinking right now. Now the only other thing that I thought of is I want to take and put, see if I can find them, a couple of these BNC connectors in there. And the reason I want those is I want to put these BNC connectors on the panel so that I can connect a direct coax, BNC to BNC coax, from there into my oscilloscope. And I may even get crazy and scale it down to make it like a 10-to-1 ratio. But I don't know, or I may just make it direct out. Not sure yet. The only issue that I have is, if you notice, all of these are insulated. In other words, they're insulated from the chassis that you mount them to. And of course I'm mounting them to an aluminum panel, which is metal. And I really kind of want to keep isolation between the two channels. Now, 90% of the situations that you're in, you know, a lot of these receivers and stuff, they have a common ground. So really the ground is tied together. But there are a few out there, especially when you get into some of these, you know, like car stereos and some of the, you know, some of the newer, what do they call them, Class D amplifiers and T-path amplifiers. Some of them actually have isolated commons. And if you tie the commons together, you can have a short. Now, this is very rare, but I've run into several of them, and there's actually a warning label right on the back of the radio that'll say, do not tie the grounds, you know, the commons of the speaker leads to ground or to each other, right and left. So for those instances, I want these to be isolated. So I may have to make an isolated plastic mount for these or something, and that'll separate the grounds. Okay. Of course, when you connect an oscilloscope, obviously what happens is you're connecting the grounds together anyways through the oscilloscope, because the commons are tied together. But if I just wanted to look at one channel at a time, I could. So anyhow, just some things I'm brainstorming as I do this. Again, it's a work in progress, and I just want this to make it a lot easier to test amplifiers and test the outputs. I want a bigger load. The other thing is, with a 300 watt resistor, this much mass as it is, and then connecting it to that metal, I probably won't even need the fan unless I'm really connecting it to a large amplifier, you know, 150 watt per channel, 165 watt per channel, or whatever. I probably won't even need to, you know, and even at that, I'd have to be running it continuous to even need any kind of cooling like that. The convection cooling should be more than enough. Even with a 50 or 100 watt per channel amp, these are rated 3 times 100 watts. So that's where I'm at. So we're going to start assembling this and kind of making it up as we go along. And I'm sure after I'm done, I will regret a little bit what decisions I make, and I'll probably want to redo it eventually. But for the time being, that's kind of where I am. And as I put the pieces together, we'll be back. Okay, I have the resistors mounted up and all the heatsink grease cleaned off of the outside there. That's always a mess. So we're all set to go there. And I did measure these, and they are spot on at 8.0 ohms when you use a regular, like a Fluke multimeter. But if I connect it up to 4-wire Kelvin leads and test it, it's about a 2/10 of an ohm below the 8 ohms. But you figure when you get the wires from the resistors out to the load, it's going to be pretty close to dead on 8 ohms. So when we make our wattage calculations, it should be pretty accurate. So there we go. So the next thing we're going to do is we're going to start thinking about how we're going to mount this in the box, and how we're going to mount our controls or our connectors on the front panel. And I'm thinking about possibly on the bench moving these 2 pieces of equipment. I hardly ever use the signal tracer, once in a while. And I do use this for leakage tests, although I do also have a Sencor up here that I use more often. But these are great for checking the high voltage electrolytics on tube gear and so forth, and I use a lot for that. So I may have to find a new home for that. This will just go on the shelf, and I can bring it out as I need it. And then that should be a perfect spot to put my my dummy load. Again, I don't know if I'm going to use the box or if I'm just going to mount this to the back panel, or how I'm going to do it yet, but yeah, we'll see. I'll like I said, making it up as we go along. Okay, so this is what we've come up with so far. Made some changes to the original design, and if you look here, there's the back side of it. There's the front side of it. So we have our 2 inputs here. Those come from your amplifier. We have an output here for the scope, right and left isolated. And I have a switch where I put these 2 80 ohm resistors, which in series with the 8 ohm resistors forms a 10 times voltage divider. So if I turn it on here, it shorts that out and makes it 1-to-1. If I bring this down, it opens it so the current flows through the resistor first, and it gives me a 10-to-1 ratio for my voltage. So if I don't have a 10x probe for my scope, this will mimic it. So that's kind of my thought process there. And you can see this is going to lead to the big resistors. And these are my outputs that can go either to my voltmeter to measure the voltage, or to the whatever else, to a set of speakers, whatever I want. And I can turn those on and off as I want without having to disconnect them and everything. That way, if they're in the binding post, I don't have to keep screwing them in and out all the time. So that's what I have so far. I'm going to start putting it together. Put a little strain relief in here for that, and that's where we're at so far. So we'll start getting this assembled and get it set up, and then guess we'll get to try it out and see how it works. Okay, so what I have is a result of when you do things off the top of your head and you don't sit down and think them through first. So essentially what I have here is I have the amplifier going into our 8 ohm 300 watt load resistor. I drew this out. And then I have an 80 ohm divider, and mistakenly thinking this is going to make a 10-to-1 divider, when in fact that is not the way this is going to work. And the reason this is not going to work like this is because the impedance of your oscilloscope is so high, you're not going to get anything up here. So essentially, this whole thing is wrong. What I needed to do was put a voltage divider circuit in here, like that, and we need to make that a real high impedance that will divide the voltage without actually causing any disturbance to our 8 ohm load. So this would have to, you know, I'm talking like maybe 100K and a 10K, or 10K and a 1K, something like that. So it's very high and doesn't affect this 8 ohm load very much. So we're going to reformulate this a little bit and then reconfigure our switches and do it the right way. So again, when you jump to conclusions and you're just coming out of the top of your head, these are the mistakes you make, and you don't think about things. So you know, you have to kind of, it pays to draw things out before you actually do them, and this is why. So, and you can see an example. I set this up so you could see an example of what I'm talking about. So I have a 1 volt load. I don't know if you could see that right there, 1 volt going across this resistor. That's what your 1 volt going across the resistor. And then I have my 10-to-1 set up through this, going from the scope, or from the BNC plug to the scope. And if you look up here, okay, there's my line. I'm set to 0. Okay, so if I go to ground, you can see right there's ground. I'm at 1 volt per division, so I only have 1 volt, just like it should be. And if I switch this out, it doesn't care either way. And that's because of the high impedance of the circuit. Okay, I did not properly design this out. So my apologies for misleading you all. I want to leave this in so I can show my mistakes along with my triumphs. And so we're going to redo this a little bit and come back. Because again, these oscilloscopes, the maximum they usually have will be 5 volts per division. And when you're looking at a really high-powered amplifier, you're going to go off scale, especially when you're looking at 2 channels at a time. Sometimes I like to run this at 10 or 20 volts per division. And in order to do that, you need a ×10 probe. And I don't want to have to hook my ×10 probe. I'd like to just have the ×10 right in here. And since we're talking frequency of 20 kilohertz and below, I don't really have to worry about the capacitive compensation and so forth that you would see that you have in the actual probes, because this is all audio frequency stuff, so it shouldn't affect it a whole lot. And we're not really looking at square waves, we're looking at sine waves typically when we're just looking at the output of an amplifier with a signal generator. So that's where we're at. We'll be back. Alright, so here's what we've done. We've made our little voltage divider, connected it back in, rewired it. I have a sine wave going in here, coming out of my port, going over to my scope. I'm trying my other scope out here. And as you can see right now, I have somewhere around 40 millivolts peak to peak floating around. And if I flip my switch to times 10. You can see it goes up to, 300, whatever, 350. It's floating around because it's measuring it. But you can see it's 10 times. So it is working. That's pretty much what I really wanted to get out of this. And that seems to be taking care of it. So there we go. It's all set to put together. And like I said, had to think this one out a little more. And I don't know. I guess the wheel was turning, but the hamster was dead on this last one. So now we got it straightened out. I used precision resistors, a 10K and a 100K, to make my voltage divider. And everything seems to be good. So on to the next part. And here it is, the finished product, complete with labels from my cheesy label maker. So everything's marked. We have our speaker inputs, scope outputs going to the scope to give you an example how this would be set up. We have the output wires here going to our resistors. We have the two outputs here going to our 2 meters, right and left. And we have our times 10 and times 1 switch. And our ability to turn the outputs to this on and off. And I can connect these either to external speakers or to my meters to measure them. So really all that's left to do is to get this mounted over here somewhere on the bench. And I'm sure you'll be seeing this in the next video that we do on a restoration of a receiver or amplifier or something. I have at least 3 more sitting on the bench ready to go, along with some other projects I'm going to be doing here. So I hope you enjoyed this, and hope you'll forgive me for not calculating properly on my resistors here, my times 10, but finally we got that worked out, so that's good. Oh, and another thing I just got in the mail today. This is a bunch of bubble wrap, but inside this bubble wrap is a transistor curve tracer kit that I ordered on eBay. I did a little research on it, and I guess for what it is, it works pretty well. I'm going to try to build it and see if we can't be able to match transistors a little bit better than just using the little transistor checker. Maybe we can, when we're doing some higher end amplifiers, we can do a little better job of matching the transistors before we install them. So that's little things to come here, and I hope you enjoyed this. I know I did. It was a lot of fun to build. And if you want to build one of these for yourself, these 300 watt 8 ohm resistors can be purchased on eBay, and really all you have to do is go into eBay and just search 8 ohm 300 watt dummy load resistor or dummy resistor or audio resistor, and these will come up, and you can buy them in pairs. They actually come in pairs, and I think it's only like $30 for these, 35 bucks for the pair. And then this box and the connectors can all be purchased, and these switches can all be purchased at Radio Shack. So you're looking at maybe $55 worth of materials and a little bit of your time, and you can build one of these yourself. I think that's not a real bad price for all that this thing can do, especially if you do a lot of testing, bench testing stereos. I'm sure this would work on car stereos and car amplifiers just the same. 8 ohms is 8 ohms. So give it a try if you're into this stuff. And more to come later, and don't forget the thumbs up if you like this, and talk to you later.